So good morning students, very good morning. Okay, so that's where we have classification of elements, last part. So we are in the last part of this particular topic, that is classification of elements. Okay, so with respect to the last classes, so we have discussed about ionization enthalpy, then electron gain enthalpy, then electronegativity. So that's what I am just mentioning the short form. So don't use such short forms in your exams. So once again I will repeat. So these are the short forms I am using to save the time. But in the exam, don't use these short forms. Write it in full form. Or you can use the symbol. Okay. So that's where we have ionization enthalpy. So where symbol can be delta IH. Electron gain enthalpy where the symbol will be delta EGH. Okay. And we have the electronegativity. Fine. So these are the things which we have discussed in the last classes. All of them, they are related to atomic size. They are related to atomic size. Okay. Now, if I see with ionization enthalpy, as the atomic size increases, ionization enthalpy is going to decrease. As the atomic size increases, ionization enthalpy is going to decrease. That's where when I am talking about ionization enthalpy, electron gain enthalpy and electronegativity, they are inversely related to atomic size. Okay, fine, not electronegativity. They are, okay, electronegativity. They are inversely related to atomic size. Now what I need to tell here is, I have two atoms. One is of large size and one will be of smaller size. One will be of large size and one will be of smaller size. Okay. Now when I am talking about large sized atom, so that's where it is easy to remove the outermost electron. When it comes to small sized atom, where it will be difficult to remove the electron. So more energy is required, less energy is required to remove the electron. So that's where we have the ionization enthalpy. Okay. So less energy is required, so ionization enthalpy will be less. High energy is required, therefore ionization enthalpy is more. So smaller the size, ionization enthalpy is going to increase. More energy is required. Okay. Now another way is, we are going to add the electron. When it comes to electron gain enthalpy, it is related to amount of energy released when electron is added to an atom. Electron gain enthalpy is amount of energy released when electron is added to an atom. Okay. Now naturally, since nucleus is near to the outermost shell, so therefore electron will be easily taken, more energy will be released. Here, since nucleus is far from the outermost shell, when electron is added, less energy will be released. Got my point? So that's where more energy will be released when smaller the atomic size, less energy will be released when larger the atomic size. Okay. And energy released can be denoted by negative sign. Right? All of us we know that electron gain enthalpy will be having negative values except inert gases. Okay. So that's where we have the effect of atomic size related to ionization enthalpy and it's related to electron gain enthalpy. Okay, so ಹಾಗಾದ್ರೆ when it comes to electronegativity, so what do you mean by electronegativity? It is the ability of a element, it is the ability of a element to pull the electron towards itself in its compound, to pull the electron towards itself in a compound. And the requirement here is that should be a covalent compound. That should be a covalent compound. So what I mean to tell here is, electron will be pulled by an element. It is applicable when elements are attached by the covalent bond, not by the ionic bond. Because in ionic bond, what will happen? The complete electron has been donated. There is no sharing of electron. So therefore, when I am talking about electronegativity, it is applicable for the covalent compounds. Okay, and it should be a compound. It cannot be a molecule. So try to understand these terminologies. Okay, so if you are finding anything difficulty, let me know. So that's where, yes, Pooja, it is a qualitative measurement. So electronegativity is a qualitative measurement. Okay, it's not a quantitative. So there is no SI unit for the electronegativity. So both of them can be go with kilojoules per mole. But when it comes to electronegativity, no SI unit. Okay, so no SI unit. Yes, Dikshit, good morning. Another one time it has to come. Okay, fine. So that's where we have the kilojoules per mole, which is applicable for ionization enthalpy and electron gain enthalpy. But for electronegativity, there is no such SI units because it is a qualitative measurement. Okay? All of you have understood? Any doubts? So that's where they are related to the atomic size. They are related to the atomic size. Okay? Now, shall we move to the last part? Okay, today we are going to finish this particular topic. Okay? So that is related to metals and non-metals. Metals and non-metals. Now in the last class, at the end, we were talking about it is the ability of element to attract the electron in its covalent compound. Yes, Pooja, I think you have missed electron, but otherwise it's absolutely correct. Yes, that is related to electronegativity. Okay, so hagadre in the last class yesterday at the end I was talking about metals and non-metals. We were talking about the metals and non-metals. Okay, so hagadre, as Stephen has written, metals are electron donors. Very good. So that's where we have the metals which are electron donors. Very good. Same way we have non-metals which will be electron acceptors. Naturally they should be electron acceptors. Hagadre, as Stephen has written, metals are electron donors. So I have written it for non-metals which are electron acceptors. Now can you tell me metals and non-metals related to metals and non-metals? Yes, Rohan, electron acceptors with related to non-metals. So if that is the case, can you relate these concept with respect to electronegativity? Can you relate this concept with respect to electronegativity? So one thing I will make it clear, listen to me carefully. All of us we know that what do you mean by electronegativity, right? All of us we know, we have studied what do you mean by electronegativity. So what do you mean by electronegativity? Yes, Rohan, I will come to that. For that only I was talking about electronegativity. So electronegativity means, that's what? Ability of an element to attract the electron towards itself in a covalent compound. That is electronegativity. Hagadre, we have another word Okay, as Rohan has written, electropositivity. Okay, so electropositive or electropositivity. Okay, so that's what electropositivity is, exactly opposite to that of the electronegativity. Electronegative or electronegativity, electropositive or electropositivity, anything is fine. So that's where we have electronegative elements, that's where we have electropositive element. Okay, so now all of you have already written the answer, very good. So electronegativity, that's where we have the electron acceptors will come. Okay, so electropositivity, that's where electron donors will come. Okay, because since they are losing the electron, or since they are ready to lose the electron, that's what they are called as electropositive. Okay, so in the last class with respect to water molecules, I have explained. Okay, so in detail with respect to dipole moment, you are going to study in your chemical bonding. But if you observe here, hydrogen will be taken with a delta positive sign, oxygen will be taken with a delta negative sign, and once again hydrogen will be with delta positive sign. So that indicates that in this case hydrogen will behave as a electropositive element and oxygen will behave as a electronegative element. All of you have understood? In this case, hydrogen will behave as a electropositive element and oxygen will behave as a electronegative element. That's why, since oxygen is behaving as an electronegative element, there will be more electron near to the oxygen. Electron density will be more surrounding the oxygen because it is also attracting the electron of hydrogen also. So therefore, since electron density is more near to the oxygen, so therefore it will be symbolically given as delta negative. It will be symbolically written as delta negative. Since electron density is less near to the hydrogen, therefore symbolically it is given as delta positive. So electropositive, electronegative. Okay. So now listen to me carefully. I will write it on one part. Okay. In a compound, I am not talking about the molecule. In a compound, one element will be electropositive or one element will behave as electropositive element. One element behaves as electropositive. Naturally another one should behave as, and another one should behave as, electronegative. Another one should behave as electronegative. Because we are dealing with the compound where different elements are involved. We are not talking about the molecule. We are talking about the compound. So therefore, I have mentioned the name in a compound. Okay? So specifically I have mentioned in a compound. Therefore, in a compound, one element can behave as electropositive, another element can behave as electronegative. Fine? All of you have understood? Any doubts? All of you have understood, right? So, why I am telling this one? Because when I am talking about a compound, by considering an element which is on the left hand side of the periodic table, listen to me carefully. When I am talking about a compound which is formed between the element, one is from left hand side of the periodic table and another one is on the extreme right hand side. So now you should tell me, which is that group element? What is the name of that element which will be the extremely left side of the periodic table? So if I consider group 1, group 2, like this it will start. So which is that element, which is that group which will be present on utmost left hand side? Metals comprises, yes Dikshit, absolutely correct. That's what I told. Metals are the one which will be dominating. Chidwan, I am telling extreme left. So therefore it should be alkali metal. Stephen is right. So you should specify not 17th group Chidwan, because I am talking about extreme left. So extreme left is which one? That should be group 1. And all of us we know that it is alkali metals. You should specify, because in the periodic table metals are dominating. So you cannot simply write it as metals, danyata, okay? So you should mention it as alkali metals. Chidwan, whether have reached you? So it should be alkali metals, okay? So yes, Rohan, that's where extreme left element, alkali metals. Now, when it comes to covalent compound or reaction, anyway, we are not going to consider group 18 elements. All of you will agree? So, whenever we are talking about reactions, yes, Vishwas, that's where we have the alkali metals. So, whenever we are talking about a compound or a reaction, so whether we are going to discuss about group 18 elements, whether we have to talk about group 18 when it comes to reactions and all, or in a compound, if we are going to talk about a compound formation, whether we are going to discuss about the group 18 elements, any one of you, yes or no? You can just mention no. Yes, Rohan, absolutely correct. Because when I am talking about group 18, in the name itself it is there, they are inert gases. Group 18 contains the inert gases. So naturally, all of you are correct. Since they are inert, that's why they are less or non-reactive. That's why they are called as inert gases. Okay? So yes, Rohan, because of their non-reactivity, that's why they have kept the name it as inert gas. Hagadru, why they are non-reactive? Because they have already in octet state. Anyway, these things we are going to discuss in chemical bonding. Since they are already in the octet state, they don't want to react with any other element. They are already stable. Hagadre, just before to group 18, we have which particular group? Naturally, it should be group 17. So when I am telling extreme right with respect to the reactivity, that means I am talking about group 17. That means I am talking about group 17. Now, can you tell me? Yes, Stefan, inert gases, they have the completely filled outermost shell. So therefore, they are not going to react. So however, when it comes to reactivity wise, so please listen to my words. So when I am telling that extreme right element in the periodic table, naturally it is group 18. But when I am talking about reaction wise or reactivity wise, I will not consider group 18, I will consider group 17. Okay? So group 17 is the one with respect to reactivity wise, it will be an extremely right side element. Okay? Now group 17 elements are called as Group 17 elements are called as, what is the name of group 17 elements? Anyone? Yes, very good. They are halogens. They are halogens. They are halogens. Now, please try to understand whatever I will be explaining now. When I am moving from left side to right side, when I am moving from left to right side across the period, when I am moving from left side to right side across the period, what will happen to electronegativity? You can just mention increase or decrease. Yes, they are halogens. Now the question here is, yes Rohan, they are salt formers. For that only I am coming now. So now across the period from left to right, what will happen to electronegativity? Whether it will increase or it will decrease? You should give the answer. Okay? Oh, okay. Stephen and Sanya, you people have written decrease. Even others can try it out. If it is wrong, we will correct it. No problem. It will not decrease. Rest of you people are absolutely correct. Electronegativity is not going to decrease when you are moving across the period, because if I take this one as an alkali metal, now the element size will goes on decreasing. Element size will be going on decreasing. When I am reaching to the halogens, they will be smallest atoms in that particular period. So what I mean to tell here is, if I take period number 2, where the first alkali metals will be lithium. If I go along that period number 2, which is that element which is present, that is fluorine. Among group 17, that is fluorine. So therefore, in period number 2, fluorine is the smallest atom and largest atom is lithium, that is alkali metal. Okay? You told fluorine is the most electronegative, sir, so it increases across the group. No group. Now when I am talking about group, it should be down the group or up the group. We will not call it as across the group. So across the period, I am talking about across the period, not group. I am not talking about the group, Rohan. Okay? So I am talking about the period number 2. Fine? So yes, Rohan, period number 2. So if I come to period number 3, that's where I will be having sodium. So sodium naturally it will have larger size compared to lithium, because it is down the lithium. It will be having much more larger size. And same logic is applicable for other elements also. They will be bit larger compared to above element. So right? So that's where I have the chlorine. So don't worry, I have not exactly written the groups and all. Rough picture I am giving. So now extreme left is sodium. In group 17, which is that element? Chlorine. So if I consider period number 3, halogens will be the one which, chlorine is the one which will be smallest atom, and sodium is the one which will be of largest size. That's where we have the alkali metal sodium. That's where we have the halogens chlorine in period number 3. Now same logic, if we move to the next period, that's where much more larger size will come. That is for potassium, which will be larger even compared to sodium. Now that's where we are going to have a bit larger compared to chlorine, that is bromine. Right? So what I mean to tell here is, if you observe these things, whatever I am telling, if you observe these things, alkali metals will be largest in their respective period. I am using the word respective. Okay? So lithium will be largest for that particular period. Sodium will be largest for that particular period. Potassium will be largest for that particular period. Same way, fluorine will be smallest in that period. Chlorine will be smallest in that period. Bromine will be smallest in that period. Like that, it will go on. Okay? So all of you are understanding what I am telling here? Okay? So what I wanted to tell here is, I can give a statement based on this observation. I can give a statement that in a particular periodic table, alkali metals are the largest atoms in their respective periods. All of you will agree with this. Alkali metals will be the largest atom in their respective periods. Hagadre, what about in this one, halogens? Halogens are the highest, smallest atoms, are the smallest atoms in their respective periods. In their respective periods. All of you will agree with this? Okay? Any doubts? So what I mean to tell you is alkali metals will be the largest atoms in their respective period. Yes, Vishwas, and halogens will be the smallest atom in their respective period. Fine. So fluorine will be smallest in that period. Chlorine will be smallest in that period. Like bromine will be smallest in that period. Like that it will go on. Hagadre. Now listen to me carefully. All of you have observed this particular statement. Any doubt in this statement? Shall I remove this part? Okay, all of you have understood, right? No doubts? If you are having any doubts, you can ask now. Otherwise, I will remove this. Okay? Fine. So, yes, no doubt. So, that's where we have the observation. Right? Now, listen to me carefully. At whatever elements we know at present, whatever elements well studied at present, I can tell that francium is the last element in alkali metal. Francium is the last element in the alkali metal. And fluorine is the first element in the halogens. Fluorine is the first element in the halogens. Observe me carefully. So francium is the last element in the alkali metals, and fluorine is the small first element in the halogens. So alkali metal francium, fluorine is the first element of the halogens. So now in that case, can any one of you tell me which is the largest element in the periodic table? Which is the largest element in the periodic table? Yes, Rakesh, I will explain. See, observe here, we have alkali metal as the first element, first group element, and halogens as the group 17 element. Okay? Anyway, when it comes to atomic size, we are not going to consider the group 18 because they are monoatomic in nature. Okay, they are monoatomic in nature. Okay, so in that case, we are not going to consider. I will come back to that one. I will repeat it once again. Then I will come back to that one. Okay, so now I have first element as alkali metals, and I have group 17 element as halogens. Naturally, since inert gases are there, which are monoatomic in nature, we are not going to consider the atomic size of inert gas with the other elements of the periodic table. Because other elements in the periodic table, they are not monoatomic in nature. Once again, I will repeat. In the periodic table, inert gases are the one which will be present in monoatomic form in the nature. But all the other elements, either they will be present in group like a metal, or they will be forming the covalent compound, or they will be forming the ionic compound, but they will not be free. Okay, so they will be present as covalent molecule, or they will be present as a metals. They are not free, but except inert gas. So therefore, we are not going to talk about the inert gas over here. Now if that is the case, I have fluorine as the first element of the halogen, and I have francium. Okay, I have francium as the last element of the alkali metal. Now which one will be the largest element among these two? And many of you have written francium. But Vishwas has written fluorine. Okay, and even Dikshit has written fluorine. No, it cannot be fluorine. So my question is largest. My question was largest. So therefore I can tell that at present, whatever element which is well studied, I can tell that largest element will be francium and the smallest element will be fluorine. Okay, so smallest element will be fluorine. Therefore francium will be the largest element. That means highly electropositive. There are many other factors, I will not make you confused, and fluorine will be highly electronegative. Okay, so if I am going with atomic size, all of you will agree? Okay, yes, fluorine will be the smallest one and largest one will be francium. Okay, now after all this explanation, now my question here is, if I go back to these two images, that's why I have not removed this one. So if I go back to this particular images, I will not talk about this one. Okay, so now energy I don't want. Okay, now among these two, where I can easily remove the electron, if I consider this one as X, this one as Y, among these two X and Y element, from which element I can remove the electron easily, whether it is X or Y. You can just mention X if your answer is X. If it is Y, your answer should be Y. Okay, all of you are going with the X. Absolutely correct. That's where we can easily remove the electron from the X compared to Y. Right? Compared to Y, I can easily remove the electron from the X. So if that is the case, if the option is given to you, among X and Y, which is metal and which is non-metal? Now first one, which is non-metal? Among X and Y, which will be a non-metal? Which will be the non-metals? Listen to me. I am not talking about metals, I am talking about non-metals. So which will be the non-metal among X and Y? Yes, purposefully I asked non-metal because already people have written X. If I talk about metal, I will get confused. So therefore I have asked non-metal. So here Tanmayi and Ganavi, how it can be X? Because non-metals are those which will accept the electron easily. They will be poor donors of electron. But according to this one, X is the good donor of electron. They are good donors of electron. That's why I have kept this arrow as it is. But when it comes to Y, they are very good acceptors of electron or poor donor. Or simply I can mention it as they are poor donor. So therefore arrow I have made it like this. So they are poor donors. If that is the case, I can tell that this one can be a metal and this one can be a non-metal. Metal and non-metals. Right? So all of you will agree with me. So that's why we have the metals and non-metals. Any doubt in this? All of you have understood? Any doubts? If you have any doubts, you can ask. So among X and Y, since X is a good donor of electron, why they are good donors of electron? Because of their larger size. So therefore they will be a metal because of electropositive character. They are called as electropositive element, metals, because they are good donors of electron. Now when it comes to Y, they are acceptor, poor donor, non-metal. That means they will be electronegative elements. They will be electronegative elements. Okay? So that's where we have the important concept. Now, you should tell me. In the periodic table, listen to me carefully. In the periodic table, which part of the periodic table will be having the non-metals in abundance? Once again I will repeat. Either you can write left or right, that's all. Yes, Vasanta. Yes, X metal. Yes. Okay? So, hagadre, when I am talking about periodic table, which part of the periodic table you can find the non-metals? Either you can write left or right, and Stephen has given answer as right. Okay, some student, P block. Okay, very smart answer, Rohan, P block. Okay, fine. But P block will becomes under right side only. Yes, all of you are right. Very good. So what I mean to tell here is non-metals are abundantly present on the right side of the periodic table. Non-metals are abundantly present on the right side of the periodic table, no doubt. They will be dominating on the right side of the periodic table. Okay? There are exceptional cases in right side also, because when you move down the group, last element in that group, normally it will be metals, even on the right side, because of their larger size. But for time being, you understand that on the right side of the periodic table, non-metals, they are going to dominate. Okay? And naturally, on the left hand side and the center or middle, we have the metals which will be dominating. Left hand side and middle, transition metals, we'll call it as transition metals. Right? Inner transition metals. So that means they are also metals only. So therefore, left hand side and the center of the periodic table, it will be metals. Therefore, metals are dominating the periodic table. Okay? And only on the right hand side, we have the non-metals. All of you have understood? Now, if you want to be much more specific, since fluorine is present on the right hand side top corner, they are present on the right hand top corner. I am not at all talking about inert gas. So fluorine, which is present on the right hand top corner, and francium, which is present on the left hand bottom corner. So now I can tell that that's where there is an increasing in the non-metallic character. When I am moving from left hand bottom side to right hand side, top side, non-metallic character is going to increase. Okay? Non-metallic character is going to increase, or vice versa. When I am moving from top right to left bottom, metallic character is going to increase. Otherwise, if it is making you confused, you can just mention that left and middle of the periodic table we can find the metals, and on the right hand side we can find the non-metals. Even that is also fine. All of you have understood? Any doubts? All of you have understood, right? So that's where we have the metals and non-metals. 1 minute, I will adjust the mobile. That's where we can find the metals and non-metals. Okay. Sir, left hand corner, right hand corner, sir, we are getting confused. We want a simple statement with respect to metals and non-metals because they are very important for our examination point of view. So make us a simple statement, sir. We don't want right top hand, left bottom side. Okay, if that is the case, I can tell that in the periodic table, this will be asked many times, they have asked with respect to metals and non-metals. In the periodic table, non-metallic character will increase from left to right side of the period or periodic table. Left to right side of the periodic table, or we can simply mention it as across the period. Non-metallic character will increase. Non-metallic character increases from across the period. What do you mean by across the period? From left to right side. Okay. Now, in the periodic table, metallic character increases down the group. Okay. So in the periodic table, metallic character increases down the group. Fine. So that means I can correlate this one with electronegativity, electropositivity. So that is across the period, electronegativity increases, and down the group, that is down the group, electropositivity increases. Down the group, electropositivity increases. Fine. All of you have understood? Any doubts? Any doubts in these statements? Okay, done. So even others can also give the answer. Okay. So whether you have understood or not. That's where we have the metals and non-metals character across the periodic table. How they will be distributed. Now when it comes to reactions, when it comes to the compound, now we can tell that since on the left hand side, that is alkali metals, when it comes to alkali metals, when they are going to interact with the halogens, they will lead to the formation of salt. Okay. So that is because alkali metals, they are having highly metallic character because they are present on the left hand side. So therefore they have metallic character. They are highly metallic in nature. But when it comes to halogens, they are highly non-metallic in nature. Okay? So due to that, they will form ionic compounds. ionic compounds. Right? So therefore, since halogens are highly electronegative in nature, with many metals they will form the salt. So therefore, as Rohan has written earlier, halogen name itself it is because salt formers. They are salt formers because with many of the elements they will form this salt. So what do you mean by salt? Salts are nothing but ionic compounds. Salts are nothing but ionic compounds. Say for example, I have NaCl. I have NaCl. So now how this NaCl has been formed? That is because we have a sodium which is highly electropositive in nature. So therefore, they are going to donate the electron to chlorine, which is highly electronegative in nature. What my point? Sodium, which is highly electropositive. Now it's going to donate the electron to chlorine, which is highly electronegative. So therefore, when highly electropositive element and highly electronegative element, when they will come across, normally it will lead to the salt formation or ionic compound. So therefore, that's where we have the Na plus Cl minus. Whether I am clear? So therefore, whenever highly electronegative element and highly electropositive element, they will interact with each other. There will not be sharing of electron. There will be complete donation of electron will be taking place. So therefore, they will form ionic compound. No covalent, they will form ionic compound. Any doubt? Any doubt in this? Any doubts? Anyway, what do you mean by ionic compound? That and all we are going to discuss in chemical bonding, but these things you should remember. Fine? Adhe riti, if I take non-metals with non-metals, if I take non-metals with non-metals, okay? Fine? So non-metals are reacting with another non-metals. It can be carbon, hydrogen. Hydrogen can behave as electropositive also. Okay, carbon and hydrogen, or fluorine and chlorine. Okay, or oxygen and fluorine. So we have some of the compound. I have taken some of the example. All of them they are non-metals. All of them they are non-metals. Okay. Now, when a reaction or compound will be formed between a non-metal and a non-metal, or an interaction between fluorine and fluorine, chlorine and chlorine, similar element, molecules I am talking about. In all these cases, it will be a covalent bond. It will be a covalent bond which will be involved. A non-metal interaction, always it will be with respect to covalent bonds. So whether I am clear? It will be with respect to covalent bonds. If that is the case, there is one thing, covalent bond. Now, if I take metals with metals, if I take metals with metals, metals with another metal or same thing. For example, sodium with sodium in a sodium metal, or any other metal like alloys. We will be having alloys, right? Where metals will be mixed with each other. So in that case, it will be metallic bond. It will be a metallic bond which will be formed. It will be a metallic bond which will be formed. Okay, all of you have understood? Any doubts in this? So ionic compound, normally or most of the time ionic compound will be formed when we have highly electronegative element interacting with the highly electropositive element. Then ionic bonds will be formed. Okay, if non-metal they are interacting, naturally it will be a covalent bond. If metals are interacting, then naturally it should be a metallic bond. Okay, so we will come to the last part. Another one thing is that there is anomalous property of period number 2 element that anyway you are going to study individually in your S and P block elements. So I am not going to discuss that one here. That is related to anomalous property. Okay, so anomalous property of the period number 2, period 2 elements. So before that, I want to talk about covalency. I want to talk about the covalency. Okay. So ಹಾಗಾದ್ರೆ valence electron is nothing but outermost shell electrons. But covalency is related to with how many bond an element can form or how many electrons it can share. So that's where we have the covalency. That's where we have the covalency. Okay. Now when it comes to alkali metals and all, when it comes to alkali metals, naturally total valence electron is 1. Total valence electron is 1 and covalency is also 1. Covalency is also 1. When it comes to alkaline earth metals, group 2, alkaline earth metals. So here valence electron is 2 and covalency is also 2. Valence electron is 2 and covalency is also 2. So therefore sodium always it will make Na plus only with one element. So calcium it can make plus 2, bivalent in nature. That's where we have the covalency. Okay, so when it comes to alkali metals and alkaline earth metals, covalency and covalent electron means valence electron, they are same. But when you move to the rest of the elements, I am not going to talk about transition D block or F block element, but I will be talking about P block element where valence and valency can change. Fine. Anyway, I will stop here. In tomorrow's class, we have to discuss about IUPAC nomenclature for those elements having atomic number greater than 100. That's very important. Please remind me. Okay. Other than that, I have to talk about valency and covalency because if I remember, someone of you had asked how to find the covalency. Okay. For D and F block, I am not going to discuss. I am talking about P block. Fine. Any doubts in today's class? Tomorrow we have to finish it off, this chapter. Okay. Okay then. Thank you. So please go through the textbook and check sheet, whichever is provided to you. And if you have any doubts, let me know. And please practice with respect to those properties, how they are distributed in the periodic table. You have to practice. Okay. So thank you. Thank you. Thank you very much. Bye. Yes, thank you.